In this video, I'll talk about the effect of dielectric medium onto the capacitance. Let's say you have two metallic plates, which is a capacitor, and then you have a dielectric here, all right? And what happens to the capacitance when you insert this medium into the between the plates, or when a medium is inserted between the capacitor, which is air filled, what will happen to the capacitance? Let's talk about this one. So let's find out the value of capacitance. The value of capacitance is about 0.89 times 10 to the negative 13. And let's see what happens to the capacitance. Does it change? Does it go up or it goes down? Let's see it. Now, the moment I am inserting the dielectric, you see it is going up. So I've minimized this one, and now you see it is going up. So what did you see here? The moment you put the dielectric into between the plates, the capacitance goes up. So it increases the capacitance. And by how much does it increase depends upon the dielectric constant of the medium. Okay, so for example, here I can change the dielectric constant from 1 to 5. The 1 corresponds to the vacuum and the 5 correspond to some other medium. Okay, the higher the value of dielectric constant is, the higher the capacitance is. Okay, you see that with the 1, which is air, let me insert fully. With the air it is 0.09. Now if I'm increasing the dielectric constant, the capacitance increases. Okay, so that means with any medium between the electric plates, the capacitance goes up. So this can be also, if you look mathematically, so the capacitance is given by kappa epsilon naught A over D. Kappa, let me zoom a little bit here. The kappa here is the dielectric constant, the dielectric constant, and epsilon naught is the permittivity of free space. A is the area of the plate, and D is the distance between the plates. So the higher the value of kappa is, or the higher the value of capacitance is, the higher the value of kappa is, the higher the capacitance will be. Okay, so now let's talk about what happens to the potential across the potential between the plates if we increase if we insert the dielectric medium. So next question we're going to talk about is what will happen to the second question. What happens to the voltage across the plate if the dielectric medium is inserted between the plates? So let me take out the dielectric medium. Now I'm going to change the voltage to 1.5 volt, and we can also measure the voltage by using these two plates, by using a voltmeter. Without any medium, so there is only the air medium, and I can read here 1.5 volt. Now let me insert this dielectric into between the plates. Now you can guess what will happen to the voltage. Okay, I'm inserting the medium now. With the medium, the voltage between the plates is not changing at all. The capacitance is changing, and the amount of charge, you can see here, the amount of charge onto the plate has increased, but the voltage has remained this constant. And why is that? The reason is these two plates, or the capacitor, is all the time connected to the battery. So the potential between the plates has to be equal to the voltage of the battery all the time. Okay, so it doesn't matter whether you insert the dielectric or take it out, the potential between the capacitor or potential between the plates will remain exactly the same because it is connected to the battery. Okay. All right. So the voltage will remain constant. And all the situation I'm talking about here, so you might have seen here, we're talking about the situation where the capacitor is all the time connected to the battery. Here the battery is never removed, so do not get confused. The situation would be different if we do not have the battery here, okay? Or if we insert a dielectric medium between a charged capacitor, that would be a different story. Okay, so now we answered two questions, and now let me answer another question now. What happens to the charge if a dielectric medium is inserted between the plates? Okay, let me take this one out. Just removing the voltmeter, and we are interested in the plate charge. So I checked the plate charge. So right now, without any medium or with just the air as a medium, the plate charge is 0.13 times 10 to the negative 12 coulomb. Now let me insert the dielectric medium. Now you can see now the dielectric medium has increased by 5 times. It was 0.13 and now it is 0.66, so definitely 5 times. Why the charge has increased? Let me answer this one. So the charge onto a capacitor is given by V times C, where V is the potential between the plate and C is the capacitance. The capacitance has increased 5 times because of the dielectric constant. The dielectric constant is 5. So you can see here the capacitance has increased 5 times compared with the air as a medium. So if the capacitance has increased 5 times, so is the charge. And you can see also from the simulation when it is at with the air, the amount of charge is 0.13. Once I insert the medium, the charge has increased by 5 times. Okay, so the charge goes up, the voltage remains constant, the capacitance goes up. Good. And now what I will talk about now, what happens to the energy stored? How will there be a difference in the energy stored? So let's go and check this storage energy. Okay, now let me minimize this one here. So without any medium or with just air as a medium, the stored energy is 0.10. Now once I insert the medium, the amount of energy stored increases. And again, if you take a look, it's 0.10 times 10 to the negative 12. When the dielectric is fully inserted, the energy stored goes by 5 times. How do we explain this one? Okay, so let's take a look. The energy stored in a capacitor is half CV squared here. The voltage remains constant, but now the capacitance has increased by 5 times. If you increase the dielectric constant by 5 times, the capacitance will increase by 5 times, and the energy stored is directly proportional to the capacitance. So the energy stored will also increase by 5 times. Okay. So the last question that I'm going to deal is very, very important. And this question is what happens to the electric field value now if we insert between the plates. So first thing we have to do is measure the electric field. Okay, so here is the electric field meter now, and now it does have multiple values. Outside there's no any electric field here. Once I put here, you can put anywhere between the plates because it is a uniform electric field values. So the electric field value is 150 volt per meter, and I'll explain about what is the sum and what is the dielectric. It is 150 volt per meter. Now if I insert the medium, or the dielectric constant value, so the electric plate value has increased by 5 times, 750, and there is another field value, the dielectric value. This value has also gone from 0 to 600, but the total value has remained is the same, 150. Let me do one more time. Just take a look at this value now. The plate value is 150. What do you mean by plate value? The plate value is between these two plates. Okay, is 150. The dielectric value is 0. There is no any dielectric, so there is no any opposite field. And the total value, the sum value, is the plate minus the dielectric value. Now if I insert the dielectric medium, you see the plate field and the dielectric field are in opposite direction. The plate has gone by 5 times. The dielectric field has gone by 4 times, but the total field has remained exactly the same. The reason the plate value has gone by 5 times because of the dielectric constant of 5. Now let me explain mathematically here. So let us assume these two are the plates, and E naught is the electric field between the plates when there is an air as a medium or there is no any other material. What happens now if we insert a dielectric medium between? So if we insert a dielectric medium between, then you see this side will acquire negative charge and this side will acquire a positive charge because of the polarization. The moment when you place an insulating material between an electric field, then because of the polarization, this side will have the negative charge because the positive charges will attract the negative charges and the negative charges will attract the positive charges. So within a dielectric, there will be an internal field. So there will be an internal field. You see the green lines, that is the electric field within the dielectric. And then the plate, the electric E plate, is the electric field still between the plates. Okay, so there are now two fields between the plate, and then there is a dielectric within the dielectric medium, and the total field will be E plate minus the E dielectric. Okay, so now let's calculate it. The plate value will increase, the electric field between the plates will increase by 5 times. What is the E naught? The E naught, as I mentioned before, is the electric field between the plates when there is no any other medium, that is just the air medium. But now once we place a dielectric, the electric field will go by the factor of K times or kappa times, where kappa is the relative permittivity, because the amount of charge stored will be has increased by 5 times or has increased by a factor of kappa. So the electric field between the plates will also increase by a factor of kappa. The electric field within the dielectric is given by this formula here. And in my next video, I will mathematically calculate Y by this factor. Okay, and the direction of the electric plate and the E dielectric are in opposite direction. The E plate is from positive plate to the negative plate, and the E dielectric is now again from positive to negative, but the positive, so this direction, as you can see clearly in this figure, are opposite. So the total electric field will be E plate minus E dielectric. So now we know the E plate and we know the E dielectric. So the total field will still be the same. But now what will differ is the dielectric field and the E plate. But the total field will remain exactly the same. And remember, the total field will remain exactly the same when the capacitor is connected to the battery. Okay, if it is not connected to the battery, then there will be a different story. Again, remember, All the scenario is when the capacitor is connected to the battery. Okay. I hope this helps you to understand what happens to the capacitance, what happens to the charge, what happens to the electric field, what happens to the voltage when a dielectric medium is inserted between the plates. Again, if you have any questions, you can write down your question in the comment section below, and do not forget to subscribe my channel. Thank you so much.